Hello everyone, welcome to another kinetic tutoring episode. Today we're going to be talking about work and kinetic energy, so let's get right into the problem. The prompt reads, find the net work done by friction on the body of a snake slithering in a complete circle of 3.93 meters radius. The coefficient of friction between the ground and the snake is 0.25 and the snake's weight is 54 newtons. Alright, so let's draw a diagram of the snake's motion really quickly. We're told that the snake slithers in one complete circle. Here we have a rough diagram of a circle, and we know that the radius of said circle is 3.93 meters. So, from here, we want to use our work equation. We know that work is simply force times distance, and our distance is going to be the circumference of this circle. So let's find that first. We know that our circumference is simply 2 pi times radius, which we're given here. So let's write distance as that. We'll get 2 pi times 3.93. Now, what's left is to find the force. And we know that what we're looking for in this particular problem is the frictional force, which we know happens to be mu normal. Since the snake is not on an incline, it's just on a flat surface, and it is not accelerating upwards or downwards, the normal force is going to be equal to its gravitational force. So N is mg, meaning that our frictional force is going to be mu mg. So let's plug that in to our equation. We'll get that mu mg times our distance, 2 pi times 3.93, will be the work done by friction on the snake. So, we're given weight in terms of newtons, which means that the weight is already accounting for gravity. So we can just rewrite mg as simply 54. We note that the friction between the ground and the snake is 0.25, so we would plug in mu, and so we get 0.25 times 54 times this distance we have here. From here, all that's left is to plug these values into our calculator. So we get 0.25 times 54 times 2 times pi times 3.93. And this gives us a value of 333. We know that work is in joules, and the only thing that I failed to incorporate into this problem is the negative sign, which comes from the fact that the snake is moving in the opposite direction of the frictional force, making the force negative. The distance negative because it is going in the opposite direction of the force. So the work done by friction is therefore going to be negative. And since we use 10 as a rough approximation for gravity, we can see that our answer of 333, or rather negative 333, is very slightly off. But yeah, we would go with option B, negative 330 joules. And if you used a value of 9.8, you would probably get a value a little bit closer to that value. I hope this helps, and make sure to tune in later for more physics tutorials.